Hello again and happy Friday. We're going to start our next unit. Okay, so this is Unit 3, Scientific Notation, which has a close link to exponents. So we're going to get through our Day 1 notes. So we're going to take the video, watch notes, or take notes, watch the video, take notes, then you're going to use your notes to complete homework Day 1, and I'll be checking everything on Monday. Good luck! We start with our warm-up. I'm going to have you try these on your own. Once you're done, come back to the video, but for now, give me a pause and come back when you're ready. Alrighty, hopefully you had a chance to try these on your own. 10 to the 4th, hopefully we recognize from our exponent unit, is 10 times 10 times 10 times 10, otherwise known as 10,000. 10 to the negative third power. Okay, remember we're not allowed to have negative exponents, so whenever we do, we flip our number and our exponent becomes positive. So this is 1 over 10 to the third power, which is the same as 1 over 10 times 10 times 10, which is the same as 1 over 1,000, which can be rewritten as 0.001 or 1,000th. And lastly, 10 to the 11th power. Is this lovely number. Go ahead and check your work, correct any mistakes you need, and then flip the page when you're all set. Our goals for today are to understand why we have scientific notation, how it can be helpful, to write numbers in scientific notation or in standard form, and then we're working our way towards comparing numbers. Okay, so understanding scientific notation. This is probably the most common example that you'll find is with astronomy. Okay, so this says astronomers have to work with very large and very small numbers. For instance, the average distance from Earth to the moon is approximately 380 million meters. Light from the moon travels to Earth at a speed of approximately 300 million meters per second. And light moves so fast through space that it travels 1 meter in about 1/300 millionth of a second. When written as a decimal, okay, you can see we get a very large decimal with a lot of zeros. Okay, so space is one of many perfect examples of when and why we want to use scientific notations. Okay, and here's the key. Okay, it is not easy to keep track of all those zeros in such large and small numbers. For this reason, scientists use scientific notation to represent and compare very large and very small numbers such as these. Okay, so this is very applicable to real life and to other topics, other sciences, so this is pretty cool. Go ahead and flip the page and we'll get started. Okay, any number can be written in scientific notation by expressing it in two parts. Okay, we have the coefficient, and we've seen a coefficient used in other ways, and we'll continue to see coefficients throughout the school year, but it's the number in front of everything, for lack of a better way to explain it. Okay, and that coefficient has to be greater than or equal to 1 and less than 10. Okay, we're also going to have a power of 10 raised to an exponent. Okay, and that exponent has to be an integer. Okay, so the gist here is that your coefficient cannot be less than 1, and it must be less than 10. Okay, and that's the key. Okay, so if we look at these examples here, it says tell whether each number is written correctly in scientific notation. If incorrect, state the reason why. Okay, so when I look at A, 2 is bigger than 1, greater than or equal to 1, and less than 10, so that's okay, and it's being multiplied by 10 to a power, and the power is an integer. So this one is okay. Neptune is about 4.488 times 10 to the 9th kilometers from the sun. Okay, again, 4.488 is greater than or equal to 1 and less than 10, so that's good, and it's being multiplied by 10 raised to an integer. So this is okay. Next one, the approximate wavelength of infrared light is 0.01 times 10 to the negative 5. The 10 to the negative 5 is okay, but it's this value here that's less than 1, and we can't have this. So this is a no because the coefficient is less than 1. Okay. And similarly, if we look at example D, a football field excluding end zones is 10 times 10 to the 1 yards long. Okay, again, the power is not the issue. It's that our coefficient needs to be less than 10. Okay, so this is no. Coefficient must be less than 10. Okay. Down below, you have problems to try on your own. So I'm going to have you do those and come back to me when you're all set. So go ahead and give the video a pause, and I'll see you in a few. Okay, now that you had a chance to try these on your own, number 1, this is correct. Number 2 is correct, but number 3 we have an issue with, and that's because the coefficient is less than 1. All right, let's go ahead and flip the page. Writing numbers in scientific notation. Okay, so you'll notice if we look at A, 427.7 is a number that's way bigger than 10. Okay, we're not allowed to have that. So what we want to do is move the decimal to a place where we have a number that is greater than or equal to 1 and less than 10. Okay, so in this case, I want my decimal to go right here. Okay, so I want to change this to 4.277. Okay, and then I want to ask myself, from this new value, how many places did I move the decimal point? Okay, so if I look here, that's 1, 2 spaces. Okay, and that's going to be our exponent. Okay, the exponent is a 2. Okay, and now when I look at this value here, I want to ask myself, what would I need to do to that number to get it back to where it started? Okay, and the answer, okay, we would have to move it 1, 2 spaces to the right. Okay, well, numbers to the right are positive. Okay, and positives will keep our exponent positive. Okay, so because I moved to the right to get back to where we started, our exponent is going to be positive. So to write this number in scientific notation, I get 4.277 times 10 to the positive 2. Okay. Now if we look at example B, this number is smaller than 1. Okay, so in order to get this to be between 1 and 10, I actually have to move my decimal over here, so that I'm looking at 7 rather than 0.007. Okay, and when I do that, okay, we move the decimal 7 spaces. I'm going to ignore this because I think it'll help us to explain it a different way. Okay, I now have 7, and to get back to where I started, I would have to move 3 spaces, right? And I would have to move to the left to get back to where I started. So that tells me that I'm going to have 7 times 10 to the third power. Okay, it's third power because it's 3 spaces, but it's going to be negative because I have to move to the left to get back to where I started. Okay? can be a little tricky to figure out which direction you're going in. So we'll keep practicing that. I do want you to try problems 4 and 5 down below. I'm going to give me a pause and come back when you're ready. Okay. Now that you've tried this, let's see how you did. For this one here, we would want to change this. Hold on a sec there. We would want to change this to 8.562. Okay, when I look at this, in order to get back to where I started, I would be moving the decimal 1, 2 spaces. Okay, so my exponent will be 2, and I would be moving to the right. Okay, and right indicates a positive, so my final answer here should be 8.562 times 10 to the second power. Okay. If we look at part 5, I'm going to be moving my decimal over here so that I have a 6. Okay, and in order to get my answer back to where it started, I would have to move 1, 2 spaces to the left. Okay, so my exponent here, I have 6 times 10 to the negative 2. Okay, and this is how we write scientific notation. Okay, and Monday when I see you, we'll practice putting these in the calculator to check ourselves and make sure that our answer does get us back to the original. But for now, we're going to do this by hand. Okay, flip the page. We have one more thing to look at. Okay, sometimes you'll be given scientific notation and you'll be asked to go back to standard form. Okay, standard form is the way we always see numbers. Okay, the normal way, if you will. Okay, so when we start with scientific notation, okay, we have to recognize that a positive exponent makes a number larger. Okay. For example, if you multiplied a number 3 to the third power, that's 3 times 3 times 3, which is 27, right? You're making the value larger. Whereas when you do 3 to the negative third power, that's 1 over 3 to the third, which is 1/27th. Okay, and fractions make things smaller. Okay, so a positive exponent makes things larger, which means you're moving the decimal to the right. Negative exponents make the number smaller. Move the decimal left. Okay, so we're really just undoing scientific notation in this case. So if we start with 7.1, okay, we're moving this 3 spaces in the positive direction. We're going to go 1, 2, 3, fill in our zeros, and this is what we're getting. Okay, for this one, 8.12, we have 3 spaces, but this is to the left because it's negative, so we're making this smaller. 1, 2, 3. Fill in your zeros. 0.00812, and then check yourself. Is 0.00812 smaller than 8.12? And the answer is yes. Okay, so we moved in the correct direction. Okay. Again, you have 2 to try on your own. Come back to me when you're all set. Now that you have a chance to practice these, let's go over them. We have 9, our decimal's right here. We have 4 spaces in the positive direction. 1, 2, 3, 4. Oops. 1, 2, 3, 4. Put my comma in. Another way to look at this, okay, if you think back to your warm-up, 10 to the 4th power was just 10,000. When you do 9 times 10,000, 90,000. Okay, so, think logical, check yourself, make sure your answers make sense, okay? And then we have 2.5 times 10 to the negative 2. Okay, 2 spaces in the negative direction. 1, 2. 0.025. Alrighty. At this point, I'm going to have you use your notes to complete homework 1. There's a front and a back. Hopefully it doesn't take you too long. There's examples at the top to help you. We'll go over everything Monday, so jot down any questions you have and enjoy the rest of your weekend. Bye.